Okay, so this is Electronics 11. Now, in the previous episode, we sort of spoke about this idea of source and destination, how we can push like a marble in from one side and come at the other, and stuff like that. One of the problems, the question arises, Electronics 11 rather, the question arises, uh, how electrons can continuously flow in a uniform direction. How electrons can continuously flow in a uniform direction. And the reason that question arises is because you would need to have basically so for instance, say so in this idea of source going to the destination, infinite capacity for electrons would be required. Infinite capacity for electrons would be required. Would be required for kind of sustained flow. And so this is a bit of a problem because well, obviously, I suppose, yeah, it's always going to be a bit of a problem. So if you can imagine, we had, if you recall, we had the marbles going in. We had the marbles in the tube, and then we would have, and then this one go in there, and then this one go out here. This area here, this would have to be like a bucket with like infinite amounts in, and this would have to be, and it would have to be infinite storage. So you couldn't really do that. So you know, so source source and destination, yeah, electrons. Source and destination would have to be infinite, wouldn't they? In terms of the storage, and that'd be the only way you could actually get the continuous flow. Now, obviously, that is kind of ridiculous because you need it to be, in a sense, more kind of you need it to be renewable, I suppose. You know, that's really otherwise it's just you're going to run out of electrons, or in the case you might run out of marbles. There's only a certain number of marbles in the world, for instance. Okay, so the solution. Okay, okay, so you can't have continuous flow like that. So the solution is a circuit. Okay, so a circuit is a never-ending looped pathway for electrons. Okay, so this means that it's just all going around in a circle, so it's never going to end. So you're not going to have to. So yes, if we have a wire, and remember we spoke, we did like a wire, and we had like the ball was like the join, something like this. So if we have a wire, or say in this case, or many wires joined together. So say in that case, that you definitely need to do that, or many wires joined together. Like over here, with which is looped around, so it forms a continuous pathway, which is looped around to form a continuous pathway. Then and I'll just go back over here now. Then we have a way to support a uniform flow. I want to actually think about this word as well, because it reminds me of this thing called uniform distribution as well. So I want to try and think about that, what it means. I'll do that in episode 12. In the recap episodes, incidentally, I do sometimes try to, in a lot of the different series I've done, these sort of educational type ones, I try to do a little bit more in the recap. I try to, think a bit more about these issues. Support uniform flow of electrons. But yeah, but it's kind of obvious what it means in this instance. We have a uniform flow of electrons without resorting to what we just alluded to earlier, to infinite sources and destinations, because that is not viable. Okay, so and besides, this is a better solution to not have to do that anyway. Okay, so what we can see then, basically, so different ways of presenting it. Perhaps we could say, so for the electron situation, we could imagine these are all electrons, and they're all going around like this. So it's all just like this, or you can imagine in the marble situation is a circular sort of thing. But yeah, I'm not sure that's. So you can imagine so the marble's going to go clockwise at the top here, and then they're going to go around here. Obviously, I haven't drawn this particularly well, and then I'm going to be anti-clockwise. So this is like marble and hula hoop. We'll put it in quotation marks here. Circuit here, and this is going to be. So this is electron flow in a path. Without beginning or end. Without beginning or end. And continuing forever. Okay. And continuing forever. Alright. So that's good. Okay. So, yeah. So each electron, let's just do maybe some bullet points here. So each electron, and then we just think about the flow here. So each advancing clockwise. So we're already sort of we're thinking about the direction of these things. So direction is very important here. Direction. So each electron advancing clockwise in the circuit. Pushes on the one in front. Okay, and so on, etc. Okay, and in the same way. As a marble field hula hoop. Okay, so it's good to have these analogies here. Yeah. Okay, so this facilitates the continuous flow of electrons. This facilitates the continuous flow of electrons without requiring an infinite source or destination. An infinite source or destination. Without infinite source or destination, we could say electron supplies. You can imagine. You can look at it like that, yeah. Okay, so okay, uh, one more thing is missing. One more thing is missing, and that is kind of the motivation for the electrons, for the motivation for continuous movement of electrons. But I'm not focusing on that here. That will come later. Put it in 13. Okay, so that's just okay. So I'm not going to focus on that. Okay, so the next thing to okay, so continuity is key. Continuity is key. Didn't really use capitalized, but it doesn't matter. Okay, so we had we recall we had like a straight piece of wire. So we recall we had this picture before, didn't we? Let's just I'll just do this. It's not a recap episode, but I'll just do it anyway. We had this piece of wire, and then we linked this here like this, and then like this, and then we had this like this, this, and we had destination and source like this in the straight piece of wire, and then we said that if we had this break here, we're going to have no flow here because of course air is an insulator. Okay, so continuity is key. All right, so in a straight piece of wire, yeah, you do need to have yeah, I mean if you've got the physical contact. But the thing is, right, this, now that we're actually almost thinking about sort of conservation here. So it's not just enough just to have the single piece of wire, and if you can get there in one direction. If we've got conservation, we're going to need to have so continuous. Okay, so continuous electron flow cannot happen anywhere in a broken circuit. So this is obviously the problem. Is this word broken is actually affecting this word circuit, because obviously a broken circuit is not a circuit. So for instance, yeah. So if say we have this, say we have something which looks like this, and then we have a break here, or we have something that looks like this. The break is here. Okay, so there's going to be no flow anywhere here. There is no flow here. And that's really the key to getting into circuits, really. There's no flow here because this break is ruining the whole lot. So there's the continuous electron flow, which is, you know, what is desired, is not going to happen. There's no flow anywhere. And the important thing to point out here is the location of the break is irrelevant. So it doesn't matter if it's broken on the left hand side or the right hand side, or if it was broken here or anywhere else. It would not matter. Okay, so that's really what I'm trying to say there. Okay, moving on. Yeah. So what do we want then? What is required then? Well, what we want is a continuous. And again, I'm just the point is I'm kind of paraphrasing, but it's important to kind of get this. And a continuous unbroken loop of conductive material. A continuous unbroken loop of conductive material is required for a sustained flow of electrons. So that is the key. So that really, I mean, that really is yeah. If the circuit is broken, and again we'll put that in quotation marks, there is no complete path. So continuous flow cannot occur. And finally, any break, yeah, I mean, yeah, any break prevents electron flow throughout. So this is an interesting word, throughout the circuit. Okay. So yeah, so I think I've kind of explained everything here that I want to do. The next episode, of course, is the recap episode. So yeah. So until then, thanks for watching.